Good morning, students. I hope my screen is visible, and I also hope you guys are ready. I would expect you to come with your notebooks. I'll be doing chemistry. It's your chemistry class today. There is some difficulty which ma'am is facing, so she is not able to take over. I'll teach you chemistry. So I hope all of you have your notebooks. If you don't have your notebooks, I will wait for a minute. Please go get your notebooks and come. I want all of you to have your notebooks. Yeah, please get your notebooks. I'll wait for a minute and then we'll continue. Meanwhile, if you're not able to see my screen, please let me know so that I can do the needful. Yeah, we are learning atomic structure. We will continue learning atomic structure. Okay, so yes, sir, your voice is trucking. It's visible. Okay, good morning. It's visible. Okay, I hope audio is also clear now. Yes, yes. Okay, good, good. Okay, good. So I hope your notebooks are also there ready with you. So let us begin our work and we will start atomic structure. Okay, so yeah, so basically always mankind, basically human beings are different types of species. They ask questions. Dogs don't ask questions, cows don't ask questions, so their life is like that. But human beings, they keep asking questions. So what somebody will say is that I'll take a substance and then I'll break it into smaller, even smaller pieces, then what will I finally get? Okay, so mankind wanted to know what will they finally get, and some people said they will get something called as an atom. And I hope all of you know that an atom is the smallest indivisible particle of a substance, of a pure substance, which is made up of only one type of which is see, this is, so it is so difficult to define an atom. So an atom is the smallest indivisible particle okay, which does not have independent existence. My handwriting will improve as we move on. My handwriting will improve. All these things you know, so my handwriting is poor. And I don't want you to copy from here. I want you to write from your own mind. Does not have independent existence. Molecule, it is the same thing, is the smallest indivisible particle which has independent existence. Okay, so while it is possible for us to get one molecule of O2, it is not possible for us to have just O. Okay, so this is atomic O. So atomic O is not possible, but it exists somewhere. It exists at high temperature and all that, it can exist. But this is molecular O. Molecular O, if it is your birthday, I can give you a gift, one molecule of O2. I can give you a gift, but I can't give you a gift of one atom of O2. Okay, it doesn't have independent existence. This has independent existence. So mankind kept asking, okay, is the atom really indivisible? Okay, is atom really indivisible? What does an atom consist of? And they asked so many questions. Now whenever okay, I don't like this which takes in chemical reaction. Okay. See, I don't like the idea of sharing slides at the end. So you better write whatever you want to write, you write now. So that later on I don't have to share, but I will share, but I don't like that idea. So I hope all of you have your notebooks and I hope you are all writing. Okay. Yeah. So this is the first slide. I hope you are understanding. Molecule has independent existence, an atom does not have independent existence. So I was just trying to explain to you what it means. So mankind asked this question, atom, is it really indivisible? Okay, is atom really indivisible? Okay, then in the around 1850, 1860, when we were fighting our war of independence, around that time, there were quite a few scientists in Europe who were doing some experiments. The specific experiment which they were doing is they took a glass chamber. They took a glass chamber and then they evacuated it. Evacuated it means what? They reduced the pressure. They kept on taking out the air from it. Okay, or gas, whatever the gas they had, they kept on taking out the gas from it. And they kept two electrodes in it. Okay, they kept two electrodes in it and they connected a very, very high potential source. Okay, and they connected a very, very high potential source. When they connected a very, very high potential source, as they kept on evacuating, they saw some rays going. First, they saw that the glass here started glowing. Okay, the glass started glowing. Then they saw that this entire thing became dark. Then when they reduced the pressure even more, they could feel certain rays going from one side to the other side. So basically, both these two electrodes, they showed some signs of particles going from one side to the other. Yeah, particles going from one side to the other. Yeah, so the moment this happened, let us see what will happen. Okay, now what they saw is, they saw, see here, there is a positive plate, there is a negative plate, right? This big line here indicates that this is a positive plate. The small line here indicates that it is a negative plate. So on the positive plate, and on the negative plate, see how, what will happen. Suppose you take a plate and you keep throwing stones at it, you will hear one pat 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 pat, one sound you will hear. So they were able to hear such small sound like this. It's not very big, that as a stone falling on a plate, but the same type, but much lesser in volume. Okay, so based on that, they were able to indicate, or also the glass here started glowing. So because the glass behind the electrode started glowing, they said that something must be hitting it. Yeah, so there was a positive plate. So now what does common sense say? Common sense says that if something is moving towards positive, it must be the negative. If something is moving towards the positive, it must be negatively charged. So towards the positive plate, some negative charges were moving. Yeah, and these were called a part of the cathode rays. Then they also saw that some particles were moving towards the negative side. So when some particles move to the negative side, then they said that if something is going towards negative, it must be positively charged. What they don't know, we still don't know what it is that went, but we only know that it is some positively charged particles were moving towards this. they call these the anode rays. Okay, they call this the cathode ray because the name of this tube itself is called the cathode ray tube. Cathode ray tube. Okay, because people saw some nice colors and all coming up, a lot of people were interested and they did this experiment. Okay, are we clear about this? Yeah, it proved the presence of electron. You are right. Pop sound, right, right. Yes, you can't understand my handwriting. Slowly you will understand. I'm sorry about it, Divya, but please give me little time. You will understand. You tell me what you don't understand and then I will reply that. This slide I thought was neat. Oh, this is not neat, is it? Okay, I will make it neater. Okay, you write down. This is evacuated. Evacuated it. Evacuated means what? Reduce the pressure. Then started glowing, glow, Glowing, glowing. Then it is called the cathode ray tube. Okay, then you have the positive plate. Positive plate is connected to the positive terminal of the battery. Negative plate is connected to the negative terminal of the battery. Okay, and then some negative charge, some particles were moving towards positive plate. Now they realize that because it must be negatively charged, so it is moving towards the positive plate. Then some particles were moving towards, excuse me, just a minute. Excuse me. I'm sorry. Yeah, so some particles were moving towards the positive plate and some particles were moving towards the negative plate. Okay. See, these rays don't produce light. These rays don't produce light, but what they did is when these were hitting the, some of them were producing light, but when they were hitting the glass was glowing. Okay, that is a property called fluorescence. Yeah, that is a property called fluorescence. Yeah. We don't know alpha rays. So far, we don't know. We have not learned. So once we learn it, we will see. Okay. So let us look at the characteristics of the of some of these rays. So this is the cathode. Uh, I mean, okay, this is the positive plate, and I'm evacuating it. And this is the cathode ray tube. This is connected to negative terminal. This is connected to positive terminal. So first thing is we'll talk about the cathode rays. Okay, cathode, CATHODE, cathode rays. Now, these cathode rays basically were moving towards the positive charge. They were moving towards positive plate. Now, because they are moving towards positive plate, what did we do? We said they must be negative charge. Anybody has any doubts on this? Because they are moving towards the positive terminal, they must be negatively charged. Okay, yeah, then they move in a straight line. They move in a straight line. How do you know? If you kept something, it kind of obstructed that and there was a shadow seen. So I know that they move in a straight line. Yeah, what I did is I did this experiment and then, okay, next one was it is attracted by the positive plate. Suppose I kept another positive plate here, then these rays seem to be moving like this. They were attracted by a positive plate. Then the fourth thing is they were deflected. They were deflected by a magnetic field also. So they kept a magnet and then they tested. If they kept a magnet and they tested, they saw that these rays got deflected. Okay, got deflected. Deflected means they were going in a straight line, but now they are not going in a straight line. They got curved and then they bent like this. Yeah. So are we understanding some of these points? They were moving towards a positive plate. They were moving in a straight line. They were attracted by the positive plate. So if you kept a positive plate in between, they got attracted towards a positive plate, and they were deflected by a magnetic field. Yeah. Then what these people did is, first they did this experiment with hydrogen gas. That inside it there was hydrogen gas. Then what they did, inside this they put helium gas. Then inside this they put nitrogen gas. Then inside this they put oxygen gas. Then inside this they put air itself. And they saw that in all these cases, the properties of the cathode ray appeared to be the same. In all cases of gases, the property of the cathode rays was found to be the same. Yeah, so what can you infer from this? They are seeing that whatever gas is there, the properties of the cathode rays appear to be the same. Yeah, I will show you second and third slide. Second slide is here. We are saying that all this work happened in the 1850s, 1860s. What is so special about 1850 and 1860? Nothing is special, just that around that time people had discovered a magnetic field, people had discovered electric field. Volta had discovered battery. He already started making batteries. So third slide I showed you. Second slide I showed you. This is the third slide. Yeah, this is the fourth slide, which I just now explained. Now I'm explaining this point that in all cases they found that the property of the cathode rays was found to be the same. Now what can you infer from this? Yeah, what can you infer from this? In all cases, irrespective of the nature of the gas, the property of the cathode ray was found to be the same. So what I could infer from this is that all gases, yeah, have this particle. All gases have this type of particle. Then they tried to bring in different elements, and then they saw that irrespective of the nature of the gas, irrespective of the nature of the cathode, irrespective of the nature of what is there at very low pressure, there are some particles which are going from one side to other side, and they said that these particles are fundamental to all matter. These particles which are present in cathode rays are fundamental to all matter. Okay, now at the same time they observed that just as some rays were going like this, a few rays were also going this way. How did they realize that? Then this electrode also started glowing. This electrode also started glowing. When this electrode started glowing, what they said is that there are some rays which are going the other side, and they called them the anode rays. and because they were going to the negative plate, they said that these anode rays must be positive in nature. The anode rays must be positive in nature. Not only that, now they saw that if the nature of the gas changes, the property, the characteristics of the anode rays change. Not the characteristic, I'll say one of the characteristics of the anode ray changes. The nature, I'll say the nature of the anode rays change. I will request all of you to write notes, because only when you write notes, I think you will understand. I will wait for 2 minutes. Only after that I will speak. Okay, I will. I will wait. Now, some of us are getting confused. They are telling, yeah, anode. Okay, they are not getting confused. I am getting confused. Anode rays are positive. Cathode rays are negative. But for all elements, cathode rays are the same. Nature of cathode rays is same. But for different elements, for different gases, nature of anode rays is different. Okay, so what is it that can be concluded, or what is it that was happening? Now, suppose you take oxygen, that is in the cathode ray tube you took oxygen. When you evacuated this and when you put a very high pressure in this, when you put a very low pressure at a high voltage, when you put a low pressure at a high voltage, because you had some atoms or molecules of oxygen, from the molecule of oxygen, some particles came out. Okay, some particles came out. These particles, because they were negatively charged, were called electrons. Okay, and then what was left was the positive charge, and that positive charge is what was going to the negatively charged plate. That was the constituent of the anode rays. So by doing these experiments, what Thomson was able to show that if you take any atom, an atom consists of a positive substrate. Okay, this was the first model of an atom. According to the first model of an atom consists of a positive substrate. This is what is called as the plum pudding model. Plum pudding model. Plum pudding model is simply Draksha Payasam model. Okay, so what they were trying to say is that the payasam which is there, that is the positive substrate. In that payasam, you had electrons, negatively charged particles. That is the draksha and kaju that you are putting in payasam. Now, when you applied a very high potential to it at low pressure, these drakshas were coming out, and they were constituting the cathode rays. So the first model of an atom says that an atom is neutral. An atom is neutral. It consists of a positive substrate. It consists of a positive substrate. Yeah, a positive substrate with the electrons embedded, embedded, embedded in it. Then the total positive charge was equal to the total negative charge. Okay, this was a model which was proposed by a scientist by the name J.J. Thomson. Okay, Thomson is fundamentally a New Zealander who was working in Copenhagen. Copenhagen is in modern day Denmark. It is in Denmark. So in Denmark, in Europe, there was this scientist by the name J.J. Thomson who created a lab, and in his lab, he was working on these evacuated tube experiments or the cathode ray tube experiments. And based on this experiment, he suggested the first model of an atom, which was called the plum pudding model. Okay, just as we put kishmish in payasam, in Europe they make pudding, and in that pudding they put plums for cherry and plums for garnishing. So the same way, because of that they called it the plum pudding model. Okay, now if you understand this, we will go ahead. What this explained is that this model has given us one fundamental particle of nature called electron. So Thomson is responsible for the discovery of electron. So I hope I have explained everything. Substrate, everything I have explained. Okay, substrate is like majority. That is the underlying part. This is the 7th slide. I will wait for 2 minutes and then we will continue. Okay, so now if you are done, then let us move on. Now, Thomson Thomson had a student by the name Rutherford. Rutherford was doing his PhD under Thomson. Okay, so they were working in the same lab. By the time this happened, like 2-3 more years later, people had discovered radioactivity. Mostly becquerel. Marie Curie. She discovered radium. Once she discovered radium, becquerel discovered radioactivity. Now, once they discovered radioactivity, they came across particles called alpha particles. Alpha particles are basically the nucleus of helium. That means helium has 2 electrons and 2 protons and 2 neutrons. It was discovered in future that these protons and neutrons are there in the nucleus. Now, if you remove these 2 electrons, what you get was helium nucleus, that is alpha particle. So alpha particle had 2 protons and it had a total mass of 4. So it is written like this. Okay, this is all later. But we know that alpha particles were some positively charged particles. That was known. By the time Rutherford knew that alpha particles are some positively charged particles. Okay. Now, what Rutherford did is, Rutherford conducted one experiment. Now, his experiment is like this. He took a very, very thin gold foil. Thin gold foil. Why did he take a gold foil? Because gold is a highly malleable and ductile material. Malleable and ductile means what? It can be drawn into very thin wires. Drawn into very thin wires. Or sheets. In gold, no, in certain parts, if you go to Rajasthan, they make sweets. On the top of that sweets, they'll put a thin gold foil. It will be very, very thin, just like they put silver foil. If you go and buy Kaju Katli, they will put one silver that is actual silver. So they're putting a silver foil. Like that, gold foil. Gold is even more malleable and ductile than silver. So you can make even thin sheets out of gold. You can make even more thin sheets out of gold. So what he did is, he took one such thin sheet of gold and he bombarded it with alpha particles. He bombarded it with alpha particles. It is like he took small tennis balls and he threw it on an open window. You have this open window. So he threw it on the open window. So if all balls go this way, what can you infer? I took 20 balls and through a window, I just threw those balls and all balls went to the other side. I didn't take 20, I took 20,000. I took 20,000 balls and I threw them and all the balls went to the other side. What can you infer? You can infer that this is all empty space. Maybe there is no grill also. Yeah. So same way, when Rutherford did his experiment and he bombarded it with gold foil, he bombarded the gold foil with alpha particles, he saw that most of the alpha particles just kept going straight. They didn't get stopped by the gold foil. This is the gold foil. They didn't get stopped by the gold foil. Common sense says that, look, you have kept a partition and if something is going and hitting it, it must stop there. It must not go to the other side. So most of the alpha particles passed through the gold foil. What does this indicate? This indicates that an atom consists of vast empty spaces. Just like the window, when I was throwing tennis balls on the window, all the balls went to the other side. When all the balls went to the other side, I inferred that the window was open. I inferred that there was no grill and it was all empty. Now, the same thing, when Rutherford bombarded it with gold foil, he concluded that the gold foil, even though it looks like a completely opaque material, there are hollows in it, so that when you push alpha particle, they just went as if there was nothing. Yeah. Now, do you understand this? Slide number 10. And slide number 11. You are understanding malleable and ductile. They can be drawn into thin wire. That's why we make jewelry out of gold. They are malleable, means you can draw them into thin wires. They are ductile, means you can make into very thin foils. Yeah. I will show all slides, but I expect you to write down. What are beta particles? We will see later. Yeah. Now, do you understand what I'm saying right now? Do you understand this? Yeah. Most of the alpha particles pass through the gold foil undeviated. Then a few of the alpha particles got deviated at large angles. That means if this is the gold foil, then a few of them got deviated this way. They passed through it, but they got deviated at large angles. Okay, they got deviated at large angles. So alpha particles are positively charged. So why did they get deviated at large angles? Who will get deviated from a positive charge? Only a positive charge will get deviated. So what Rutherford concluded is that there must be something in the atom which is positively charged and which is pushing these alpha particles away. There must be something which is positively charged and pushing these alpha particles away. See, understand that suppose nucleus was an atom was a continuous here. If the atom was continuous, when you were throwing alpha particles, they wouldn't have crossed it. At least all wouldn't have crossed it. Maybe one or two may have crossed it. But the fact that all of them crossed it or majority of them crossed it indicates that there is a lot of hollow space. So earlier we said that pisum which was there, now that pisum is not there. So that pudding is not there. Okay, then they are saying that few of the alpha particles got deviated, which indicate the presence of a negative, indicate the presence of a positive charge. Yeah, and very, very, very few particles, 1 in a million, 1 in a million was reflected back. Very, very few particles, like 1 in a million was reflected back. That means what? The alpha particle was going on its path, it faced a positive charge. Because positive, positive, there is repulsion, the alpha particle went back. Do you understand? Now, based on this, Rutherford constructed a model of an atom. What Rutherford said is that an atom has a positively charged center and the electrons must be revolving around it. Yeah, it has a positively charged center and the electrons must be revolving around it. When you look at this, this looks like the solar system with the sun at the center. So this is called the planetary model, Planetary, planetary model of an atom. This was called the planetary model of an atom. Do we understand Rutherford's experiment? Can we make some good notes about it? Yeah. Yeah. Can you quickly make some notes so that we move on fast? Here is slide 9. I will wait for 2 minutes and then I will move. Whatever you understand, I don't want you to write exactly what I am writing. Okay, I want you to understand and then I want you to write. So whatever you understood till now, please make sure that you're writing it. So I am being asked this question: did Rutherford prove his teacher wrong? Well, I won't say he proved his teacher wrong. I would say he developed over what his teacher said. He developed over what his teacher said. His teacher said something based on the technology which was there as long as his teacher was teaching. Now, as times passed, technology changed. When the new technology came, with the new technology, that is with the discovery of alpha particles, Rutherford was able to do that. Rutherford still continued to work in the same lab as Thomson, and they both were great friends. So I will tell you the planetary model. So according to Rutherford's planetary model, the atom has a positively charged center. An atom has a positively charged center. Now this is called the nucleus. This is called the nucleus. Now the nucleus contains the entire mass of the atom. It's so heavy. Okay, it's so heavy. That is why the alpha particles went back. The gold foil didn't go. The alpha particles went back. So he said the nucleus contains the entire mass of the atom. The electrons revolve around the nucleus just as the planets revolve around the sun. The electrons revolve around the nucleus just as the planets revolve around the sun. And we got the planetary model of an atom. Yeah. Who gave us this planetary model of an atom? This planetary model of an atom was given by Rutherford after he did his gold foil experiment. Okay. Now, this gold foil experiment and Rutherford's work happened in the city of Copenhagen. This happened in the Copenhagen, and Copenhagen is somewhere in modern day Denmark. Okay, not modern day, it was always in Denmark, it's in Denmark. Then what happened is we have another scientist by the name Maxwell. Maxwell is a German scientist. He did a lot of work in motors and thermodynamics. He gave a lot of statistics to the world. Statistics. Statistics. He gave a lot of statistics to the world. Okay. So Maxwell showed that a charged particle releases energy in the form of EM waves if it moves in a circle. So what Maxwell said, that a charged particle releases energy in the form of electromagnetic waves if it moves in a circle. He didn't say circle, he says if it is accelerating. But if something is moving in a circle, it is accelerating. Yeah. So what he said is, you are right, nucleus is here, the electrons are revolving, but these electrons are constantly giving energy. If they are giving energy, their energy will reduce. Then electrons are negative, nucleus is positive. So if their energy will reduce, what should happen? They should slowly come like this, and then they should fall inside the nucleus. Do you understand? So the electrons cannot move in a circle, they must spiral and come and fall into the nucleus, is what Maxwell said. Do you understand what Maxwell said? Can you make some notes here? So you make a note as Maxwell's objection to Rutherford's planetary model. So we are trying to understand the objection to Rutherford's planetary model. So what is the objection? The objection is coming from the fact that if a charged particle moves in a circle, it must give energy. If it is giving energy, its energy must reduce. And ultimately, if its energy is reducing, it will move and collapse into the nucleus. Yeah. So can you make some notes? Any questions? Proton, it is collapsing, sir. Got it, sir. 12th slide. Can you please show all the slides? I will show. J.J. Thomson, kind of. Yes, he did. Rutherford. Yes, sir. Done, sir. No, sir. No doubt. Can't under. Sir, I have a doubt. Is there anyone called Goldstein? Yes, there is. Thank you for teaching, sir. Without doubt. Proton as it is given in the book. Yes, Goldstein is there. Oxidation. What is this? Okay. Okay. So yeah. So don't worry what we have done. Okay. So what we are saying is Maxwell said that the electron must fall in. Now what we have to do is we have to go to the, so we said J.J. Thomson, J.J. Thomson student, Rutherford. Now comes Rutherford student, Bohr. Oh, I don't know the spelling of Bohr. I've forgotten BHOR or BOHR. I keep teasing people and then I keep making that mistake. You check. Maybe it is BHOR. Bohr. Yeah. Now, Bohr was a student of Rutherford. He was doing his PhD under him. Now, when people said Rutherford, you are wrong. I don't know. I like this spelling more than this spelling. So anyway, you check it up in your book. So when people said you were wrong, Bohr didn't like it. When people said his teacher was wrong, Bohr didn't like it. He was very clear that they were on the right track, but they were missing a few parts. All this was happening in Copenhagen. This is in Denmark. Now, Niels Bohr is a very interesting person. Very interesting person in the sense that he was a very, very open-minded person. So what Niels Bohr did is that he was able to invite all the leading brains all over Europe to come and work with him and with Rutherford in their lab. So he created a lab in Copenhagen in Denmark, and he invited a lot of people. Planck, Max Planck. Max Planck was Maxwell's student. Okay, then he invited de Broglie. Then he invited so many. He invited, there were, once upon a time, there were around 30 people working with Niels Bohr. And out of that 30 people, 20 people got Nobel Prize. Yeah, our own physicist by the name Homi Bhabha, he also went there, but unfortunately he passed away in a plane crash. Homi Bhabha was a very, very top class physicist who was there right at the top. Had he lived for a few more years, he would have got us a Nobel Prize. Okay, so this is what was happening. So in the next class, we will read about Bohr's contribution. What did Bohr do? And we will move towards atomic structure and learn more about atomic structure. Here are the different slides which I have. So this is the first slide where I was trying to explain to you that human beings ask questions, animals don't. And it is our ability to ask questions which enables us to develop. So we all should. So we should know the difference between an atom and a molecule. Then I was telling you that a molecule exists, molecule has independent existence, but atom doesn't have independent existence. So atoms are indivisible. Then cathode ray experiment, I was talking to you about an evacuated experiment. I was talking about the different kinds of rays which come out from there. So there are the cathode rays which move towards a positive plate, and then you have the anode rays which move towards a negative plate. Then I was trying to tell you about some of the properties of the cathode rays. They move in a straight line towards the positive plate. Then they are attracted by the positive plate. Obviously, that's why they move towards a positive plate. Then they are deflected by a magnetic field. They cast a shadow. They have momentum. I have not written it here. They have momentum. How do you know they have momentum? If you keep a small flywheel, that flywheel starts rotating. If you keep a small flywheel in its path, flywheel is a wheel of this kind. If you keep a flywheel in its path, the atoms hit it and then they make it rotate. So the flywheel started rotating. So they have momentum. Yeah. Then I was trying to tell you that irrespective of the nature of the gas, the properties of the cathode rays were similar, but the anode rays were different. So from here, what Thomson concluded is that, look, there is something positive, and then there are these negatives, and an atom consists of that, and that is what we call the plum pudding model. Yeah. Then after the plum pudding model, Thomson went, and then Rutherford came. By the time radioactivity was discovered, people had alpha particles with them. Once they had alpha particles with them, Rutherford thought of a wonderful experiment wherein he bombarded a gold foil with alpha particles. Why did he take gold foil? He took gold foil because gold is highly malleable and ductile. Malleable and ductile means what? It can be drawn into real thin sheets, so thin that there is just one molecule or two molecules. There is one atom or two atoms there between, so that he can study the nature of the atoms. Had he taken a thin gold foil, this experiment might not have worked out. Then he saw that most of the alpha particles were passing through. If there was a lot of PISM and the alpha particles were there, they would have been stopped by the PISM, but they were not stopped, which means that an atom has vast empty spaces. Then a few particles were deflected at large angles, meaning that there must be something positive which is pushing away the positive charge. Very, very few alpha particles, almost 1 in a million, got reflected back, indicating, one, that there is a positive charge. Two, this positive charge is very heavy, so heavy that it is able to reflect the alpha particle. So from there, he suggested the planetary model of an atom, because that was the solar system. People knew about the solar system. We are talking about almost 1880, 1890. Then around 1900, Niels Bohr came, and he revolutionized the science and physics. But that we will keep for the next week. Okay, so this is slide number 15, and this is slide number 16. There was the objection to Rutherford's model came from Maxwell, who said a charged particle liberates energy. So if the electron is liberating energy, ultimately its energy will go away and it will stop, and it will get attracted to the nucleus, and it will go inside the nucleus where positive negative will combine. So yeah, so this is the thing, and then we meet again next week. Next week when we meet, I'll only meet you next week also. And when we meet next week, I'll explain you all these things. Okay. Yeah. Show all the slides, please. I showed. Okay. Okay. What is flywheel? Flywheel is a small light wheel which can move. Yeah. Yes, he invented KLMN. 2n square, yeah, is Bohr's law. Okay, BOHR, okay, no problem. No problem. That's it. Okay, don't worry about the spelling. You guys get it right. Okay, prove your teachers wrong and make sure that you know more than your teacher. Yeah. Okay, good. Thank you. So see you again next week. Yep. Bye.